Hello everyone, my name is Shreyas. Welcome to my YouTube channel. Today we are going to discuss about a problem called subarray with given sum. In this particular problem, um, we are will be having two parameters to the functions, that is two input parameters. One is an array and another is a sum. What we need to do in this particular problem is we need to find the subarray in the array where the sum of the elements inside the subarray, that is arrays subarray, is equivalent to 17. What are subarrays? If you consider this particular problem, uh, we can say 4 is a subarray, 4 comma 8 is a subarray, 4 comma 8 comma 12 is a subarray, 4 8 12 and 5 is a subarray, 8 and 12 is a subarray, 8 is subarray, 8 12 and 5 is subarray, 12 is subarray, 12 5 is subarray. These are all the subarrays which are having. These are called subarrays, and we need to find in which subarray it's going to sum of elements in the subarray which leads to sum 17. Here if you can see, the subarray 12 plus 5 is equivalent to 17. That's it. This is the main idea behind the problem. How we are going to solve this problem? If we consider the naive approach, that is the easy method, it's just simple, where we will be having two loops, and inside the loop we will be checking whether hmm, uh, we will be adding the elements and we will be checking whether it's equivalent to sum. If it's equivalent to sum, we are going to return, yeah, the number 17 is present in subarray, and we have written the number. That's what I have explained over here. uh, Here I'm going to explain an iteration. Suppose these are all the index 0 1 2 3. I'm considering the index 0, and I'm going to check with all the other numbers in the first iteration, and I'm going to check take index 8, and I'm going to check whether that number is equivalent to sum, and I'm going to sum these particular numbers to check whether these numbers are equivalent to 17, and then I'm going to take 12, and I'm going to check whether this is equivalent to 17. This is the base idea over here. If you consider 0 index, that is 4, 4 is not equivalent to 17. We'll be starting from 4, we'll, and we'll be checking with that e means end index. End index is 0. 0 comma 0 is 4 only. 0 comma 1, start from 0 and end at 1. We are going to get sum 4 plus 8 is equivalent to 12, and we are going to check 4 plus until index 2, 4 plus 8 plus 12 is equal to 24. Here, similar to this one, we are going to do this for the all the index, and it when we come to index number 2, and when the start index is 2 and end is 3, we are going to get the current as 17, and we are going to get the sum, that is current is equivalent to sum, and we are going to return true. That is the naive approach, and this is the program. Right now I haven't implemented, in the sense like it's not in a readable format for you guys. I'm just explaining the logic. Please um, go and try to code on your own. It's just a simple logic. Here if you can see it, like there is one loop and there is another loop. In the another loop, I'm going to start the index from I. I have iterated j is equal to I. If you can see over here, 1 1 0 0, I'm going to start from this particular value. If I is 1, j is also 1, and it's run until length n. And here I'm going to check, we are initializing current as 0, and current is equal, this current plus equals to means current is equals to current plus array of j. At first current will be 0. When we come to first iteration, it's going to be 4, and second it's going to be 4 plus 8 12, similar to that. And then we are checking here only if array, that if this particular current is equivalent to sum, in that case we are returning truth, telling the number is present. So if you see this problem, do you find Any iterations where we are simply doing? Yeah, definitely you can find that particular thing over here. When we are iterating here the sum is 17, the number which we need to find. Here we are simply iterating when the sum of these particular numbers is 24, and we know if we go to next iteration we will be getting more values, we are not going to get less value, but still we are iterating. These two are waste. So how we can optimize this problem? And right now if you can see there are two loops, so the time complexity of this problem is big of n square, and auxiliary space we are not using any extra space to store anything, so it's a constant space, so big of 1. So how we are going to optimize the problem? So here we can see that I have taken the same number and I'm going to iterate just only once from 0 to the length of an array, and I'm going to check when it's similar to that one only, but when the current is greater than sum, we are going to make sure uh, we are going to remove the first elements. If you can see over here, 4 is not greater than sum, 17, 4 plus 8 is not greater than 17, um, but 4 plus 8 plus 12, that is 24, is greater than 17. So what we are going to do, I'm going to remove the first element. We need not to worry, we can remove the first element and we can check whether that particular number is uh, equal to sum. We are going to check 8 plus 12. I have removed 4. You consider 4, 8, 12. I have removed 4. I will check whether this number is equivalent to 17. Sum of these two is 20 and this is also greater than 17. So what I'm going to do, I'm going to remove this one again. So the remaining number is 12, which I have written over here, and 12 is less than 17. So I'm going to iterate the e value which was there at 2 to next value, that is 12 to 12 plus 5. E value will be increased to 3, and that is equal to 17, and 17 is equal to 17, and it's true. So how many iteration it's taking over here? Here is the code. Here if you can see, at first we are going to initialize the s value as 0 and current value as 0, and we are iterating from 0 to length, and current is getting iterated, like current is 0, 0 plus 4, if you can see it's 4, and in the and 4 is not greater than sum, or either the 4 is not equivalent to sum, so it's going to get into next iteration. E value is 1. At that time it's the current value, that is 4 plus 2, 4 plus 8 is equals to 12. 12 is not greater than sum and 12 is not equivalent to this thing, that is 17. Again it will go to next one, that is current value is 12. 12 plus 12, it's going to 24. So at this particular point the current is greater than sum, so here we are going to check, we are going to remove the 4. So current value, which is 24, will be subtracted with 4. 24 minus 4, that is equivalent to 20, and again it's going to check uh, 17 is less than 20, that is current value, so again it's going to do the same. It's going to remove one more element that we are seeing over here in this part. So current value is 20, that is 20 minus uh, 8, it's going to become 12, and 12 we have written over here. And the s value also usually increased. At first s value is 0. When we encountered current value uh, as 20, at that time s value is increased to 1, and when we did the iteration where we get 12, current value got increased for one more value, that's equivalent to 2. And in from 2 we are going to check 12 is not greater than sum, or 12 is not equivalent to 17, so we are going to uh, check increment the value of e, that is s starts from 2 and e goes to 3. At this particular point we are going to this current value, this particular point 12 is equal to 12 plus 5, it's equivalent to 17. it won't pass this particular condition, but it's going to test this one, and we are going to get the result as 17 is equivalent to sum that is which we have given, that is 17, and it's going to return true. This is the whole scenario, and what is the time complexity over here? You might think it's n square. No, it's definitely not n square. Why? Because we are iterating it this for n times, and we are incrementing I value. And if you can see some, if you see this particular two part, it has reduced the iteration. So max in the worst case, it's going to have n extra iterations, that is n plus n, it's going to 2n. So 2n can be represented as big O of n time complexity, and the space it's going to take is big O of 1. And so we can say this is the most optimized solution, and this is how we can solve this problem. Thank you for watching this video, and please try this problem in your machine, in your computer, and please let me know uh, whether you have understood these things in your comment section, and please subscribe to my channel to watch the next videos. Thank you.